So, as I was talking about the short side being opposite the angle, this is presenting kind of an unusual situation where we have two possible triangles. So I need to try to review this with you because it really needs to make sense. So the original triangle that I drew went from A to B to C, this side length being 5, shorter than the other side, but it is opposite the angle. As we talked about, the angle B we don't know anything about, nor do we know anything about side B. So we don't know if angle B is the bigger version or the smaller version. We don't know if side B is the bigger version or the smaller version. I don't know if angle C is here, or maybe angle C is this angle right here, which is obtuse. So the triangle could actually look like this, and I didn't know it based on the way it was drawn in the beginning. You can't do this little trick with the other version, the one where it was the long side opposite the angle. You can't move this over to the other side, otherwise it breaks the triangle up. It no longer will be a triangle. So, if I use my calculator, making sure I'm in degree mode, and go through my law of sines here. So we have 8 sine 32 divided by 5. I get 0.848 for sine C. It is approximately 0.848. And of course, to find angle C, I am going to invert the sign, because the only way we're going to find the actual angle is to invert the sign of that answer. So 57.98 degrees. C is approximately 57.98 degrees. Now that is the acute angle version. But I hope you realize that this little part is isosceles. And the base angles of an isosceles triangle are the same. So this would be 57.98, and this would be 57.98 if we were talking about this triangle. So what would that make the obtuse one? So the obtuse possibility would be, you guessed it, 180 minus 57.98. And I'll use that answer feature, which is found on the negative at the bottom of the calculator. So 122.02. Now, in either one of these cases, if you take 57.98 plus the original 32 degrees, 57.98 plus the original 32 degrees, remember there has to be a third angle, angle B at the top. Well, if you take 57.98 plus 32, there's always going to be enough room for a third angle. Always, always, always. And in this case, because we're dealing with the short side opposite the angle, you will also have enough room for the third angle. If you try this little trick on the other one, the one solution case, you will find that it goes over 180 degrees. For instance, remember back over here on that example where we got 11.69? Suppose I thought that this was the same type of situation where there could be an obtuse one. And so I calculated the obtuse angle at 168.31 degrees. Remember, we started off with 42.5 degrees in the triangle. So if I take that plus 42.5, do you see how it goes over 180? That's not even a possibility. That's why you know that it doesn't work. The obtuse possibility only works, and you'll have to give me both answers on this particular question. But the obtuse one only works when the short side is opposite the angle. So get that in your mind. Short side opposite the angle, 2 solutions. Long side opposite the angle, 1 solution. Now, in Algebra 2, we went over this, but guess what? We never told you about the 2 solution possibility. Every single question we gave you was the long side opposite the angle because we never wanted to face the two possibility. Either that or we just ignored it and didn't talk to you about it. Because we just wanted to get you the basics of here's the law of sines, how do you use it, how do you find sides, how do you find angles. Now, in kind of a little bit of, I shouldn't say unrelated, but kind of a commercial interruption in this section is this notion of finding the area of a triangle. We can find the area of a triangle. They chose to mention it in this section, maybe because sine is involved, although they could have put it in section 5.1, but you know that's all about right triangles, so that might have been confusing. I know that you guys are very used to 1/2 the base times the height to find the area of a triangle. Well, we can actually split a triangle, which I'm not going to look at the proof. If you want to look at the proof in the book or online, you can find it. We can actually split a triangle and find the height. And what we find is that it's this a sine c is actually the height of the triangle. So there's still 1/2, there's still the base, and a sine c is actually the height. But we can actually rewrite the area formula for a triangle as 1/2 AB sine C. Okay, now, my fancy way of remembering that is to think about taking a half a day off school. Call it a half absence. Okay, half absence. Half absence. Okay, that's my kind of goofy way of remembering that. I do want you to kind of clue in right here. What's the relationship between the side lengths A, B, and the angle C? Well, if you notice, the angle is between the two sides. So if you give me any triangle in the world, and you ask me for the area of that triangle, I can take 1/2 side sine of 35. .68 approximately. Now, don't ask me why people throw cosine into that equation. For some strange reason, they like to throw cosine in. I mean, does the word absence have a cos in it? I don't think so. All right. Talk to you in class. That's that was part 2 of the video, and make sure you watch the law of cosine video as well.